Hello, flatties and globe defenders. It's Critical Thing from Down Under. And here is your second chance for you flatties to prove you're flat earth. So this is the second challenge. It's marginally more difficult than the first challenge, which was the equinox challenge. In this challenge, you can look at the sunrise and sunset direction and prove that it matches your flat earth model. That's it.
Now this challenge is very similar to the equinox challenge in that it's looking at sunrise or sunset, but can be done at any day of the year. So on the globe model, we have timeanddate.com, which predicts the sunrise, sunset, times, angles. So there's a full description of what should happen on a globe model. You don't have to work anything out to check if your sunrise or sunset matches. So on the flat earth model, this is the world according to D. Marble about what we know. And Earth is flat stationary and the sun makes a clockwise circuit over the face of the Earth. And this is traditionally represented by an AE map. In this case, the position of the land masses doesn't really matter a lot for this particular experiment. What's important is the position of the sun on your model. So you do actually have to know the time of the year for your flat earth model so that you can work out which part of the circle or spiral it's on, because in the northern summer the sun goes around the Tropic of Cancer and where's that here? That's there on this map. And on the equinox it goes around the equator, and at the southern hemisphere this summer it goes around the Tropic of Capricorn. So you have to do a little bit of working out to work out where your sun is, and according to the what o'clock it is also a rough idea of where your sun is around the circle. So if you're in the US, mid-US for instance, and it's midday, well, depending on how your time zone is constructed, that may not be directly overhead. So you should actually try and figure out the time when the sun is at its zenith, so that you can get an accurate number for whereabouts around the circle that your sun might be, because you can just use it to work it like a clock face. So I went out on September the 1st. I'll show some videos after this, and I was looking at the sun rise in this case, and this is a famous building in Brisbane, 1 William Street, and where I was standing I'll show you in a minute. So there's the sun. Now it's a little bit after sunrise because there was a dust storm at the time, a very rare dust storm, so visibility was not the best. So this is a couple of minutes after sunrise, but it's close enough for the purposes of this experiment. And so where I was is Mount Cootha Lookout. It's the only place in Brisbane where you can take this kind of shot. So the Brisbane city is there, and the lookout is there, and where I was standing is right there. So as I said, I'll play the videos shortly, and you can calculate this. You should be. There's enough information there for anyone to calculate the angle of the sunrise. And I can't verify the exact time of the sunrise because I couldn't see the sun until a little bit after, but there is a time verification in the video of the time when the sun was at this position. So anybody should be able to calculate the direction which the sun is in, and then you verify that against your model. So that's pretty much how you can prove flat. If you can match it up with your flat Earth model, you've proved the model. If it matches better with the globe model, well, you're going to have to consider the possibility that the Earth is a globe. So I'll just jump to the videos now. So this is a few minutes before sunrise, and I'm just doing a scout around of the location. You can see that this is part of the lookout, and there's the Brisbane River, that's Brisbane City, and I'll just run this now. So I'm just going to pan around, and you see there's a few people there waiting for the sunrise. It's a nice spot to see the sunrise. So I'm going to also, the moon was in the sky, so I'll just show that. The moon was up there. So that's all we need from that one. So here's the video from where I was first able to make out the sun through the dust storm. So I've got an overall picture of the Brisbane CBD, and I can just see the sun right there, so I'm going to zoom in on that, and there it is. It's right near the top of that building, 1 William Street. And I'm going to verify the time by zooming into the clock. It's on top of one of the city buildings, so it's actually 6:04, which is a couple of minutes after the official sunrise. But as you can see, the haze is very thick right near the horizon, so it's very difficult to see through that. But it's a wonderful sunrise. I'm just going to show a couple more of the photos I got, because these are very rare photos now because of the dust storm, and such interesting photographs. So I'll just show the ones that, some of the best ones I've got. Now there are certain days of the year in which on a flat Earth that the direction will match up with what the globe Earth will say. Certain locations and certain days of the year. Now, if you happen to pick one of those days and you find that it matches, and it also matches globe, that's not proof of flat Earth. I just want to make that clear. So you have to pick a location and a day and make sure that there is sufficient difference between the two models so that you can clearly discern which model best fits the position of the sun where you are. So I'll give some more instructions on how to do this following this now. So let's go through just a little example of how you might work out the position of the sun on a flat map. Now, first of all, let's assume, let's just pick a location sort of like, that's easy, somewhere around Houston in Texas. Now, you should rotate your map so that your location is down near the 6 o'clock position. It's just to make it easier. because towards north is 0 degrees. So when you look up your timeanddate.com to see what the globe model will say where the sun is, it's assuming north is 0 degrees. So you should try and orientate your map the same. If you can't orientate your map like that, just remember that's where your 0 degrees line is. Now, to work out the position of the sun, now each of these quadrants is 6 hours, not 3 hours as your normal clock face, so just like a 24-hour clock. So over here in the Sahara Desert is 6 a.m., roughly noon. Again, it can shift by an hour or two depending on your time zone, but you can approximate it at noon at your location, and then 6 p.m. is in this case over in the Pacific Ocean there. So now the position of you, so you've got the time of day where your sun might be, and just then you need the month. So this is the equinox line, the red one. It's for September the 23rd this year, Tropic of Cancer. So we pass that, it's June 21st this year. So the sun will go in circles that will slowly creep down wider and wider circles on your flat map, and culminating at the equinox and this red line, and then go south, further south, until it gets to the Tropic of Capricorn on December, somewhere around the 22nd. So you have to sort of roughly estimate, like if it was in the middle of October, you'd probably be somewhere down there. So you have to estimate, because you do not have a sun calculator tool like we do on timeanddate.com, or you could approximate it by going to timeanddate.com and looking where time and date says, and then place it on the map according to these land masses here. That's another way of doing it. And so you should pick a time and when the difference between what the globe model says and what the flat model says is big enough so that you can notice it. So it's as I said before, it's no good picking one where they're the same, then go, oh look, it's flat, just the same as if you went to Alaska, for instance, and saw the sun go around in a circle and say, oh look, it's flat. Well, you know, the globe model works exactly the same. So you actually have to pick something that differentiates between the two models. Like, for instance, if you wanted to see if the sun went in a circle or not, you go to Antarctica, because that's in the globe model, the Antarctica sun goes in a circle in the summer, southern summer. And in the flat earth model, it's completely different. So that's how you would tell between the two. And so this position of the sun, any time of the year, you can make sure there's going to be a difference between flat and globe. So I encourage all flat earthers to do this. I mean, let's see which model fits the best. You can prove for yourself that it's flat very easy with this. Okay. Thanks for watching, and I encourage you to work the example that I've given in this video, and I encourage you to do this yourself. So please do subscribe if you enjoyed any of my videos, and I'll be back again soon. Thank you very much.